Significant digits are really an important concept when you're doing calculations in science. So significant digits, or SIGDIG as we often kind of abbreviate it, significant digits have to do with measurement. And so measurements have a degree of precision. And so different scales, precision, different scales have different number of decimal places, I guess is kind of the simplest way for me to think about it. So in our chemistry class, our scale can read like it's going to be set at 0.00. So it's accurate to 100th of a gram, which is quite accurate. And that number is going to, our significant digits need to reflect that amount of precision. So if we had a number like 1.23, it's pretty easy to spot the number of significant digits. This has 3 SIGDIGs. It only has 3 digits. So they're all significant. But it's a little bit less obvious if you have 1.20. This also has 3 significant digits because the 0 here is a measured quantity. So we're saying that it's actually 0. We're not saying that it's just gone. 1.2 would only have 2 SIGDIGs because the 1 and the 2 are both significant. If I had 1.20, it would again have 3 SIGDIGs. And so all of those numbers have a meaning. And we have to be a little careful when we're writing in zeros or dropping zeros, whether they're significant or not. Were they measured or weren't they? The scientific notation is pretty straightforward. If you had a number like 1.23 times 10 to the 4, these are the significant digits. This is the power. And power has to do with like decimal places. And so this number, if we were to write it entirely out, would be 12,300. And this number, written this way, has 5 SIGDIGs. So one of the reasons we put things into like scientific notation or go use like kilos or megas or something like that is so that we can reflect the actual number of significant digits that we should be reflecting. Now our general rule is zeros that trail. So trailing zeros are significant. Zeros that are in front are not significant. These are placeholders. So they're not significant. But if there was a 0 on the end, this would have 1, 2, 3 significant digits. If we have a digit 0 in the middle of a number, it is also significant. So if this was the number 0.002203, this has 4 significant digits. And so when we talk about significant digits, it's important to be able to calculate the number of significant digits. We've got a few other rules that kind of apply. So for SIGDIG, when you multiply or divide, your answer can't have more SIGDIGs than your least precise number. Your least precise number. So whichever number has the least number of significant digits is the most significant digits that I can report in my answer. So I have to round off to make that happen. Whereas when you add and subtract, your answer can't have more decimal places than the least decimal places. So we'll show you an example of some of these, but essentially when you multiply and divide, you're going to just, whatever your least number of significant digits for a measured quantity are, is the most that I'm going to be able to report my answer in. If I'm adding and subtracting, then I can't have more decimal places than my worst measurement, essentially. So we'll show you what that kind of looks like. Here are some questions. So our first question is a multiplication division question. So what is the mass of 0.32 mole of water? So the number of moles equals mass over molar mass. So the mass equals the number of moles times the molar mass. The molar mass of water, it has 2 hydrogens at 1.01 gram per mole, and it's got 1 oxygen at 16.00 gram per mole. If you don't know that, look up molar mass. Its total molar mass is 18.02 gram per mole. So this is going to be 0.32 mole times 18.02 gram per mole. Well, I'll put this into my calculator. I get 0.32 times 18.02. I get 5.7664. But here, this number has 2 sig digs and this has 4. Well, this number has 5 significant digits that are reported. I can't report all 5 of those. I can only pick the least number of sig digs. So this will be 5 point, and then I'm going to take the second significant digit and I need to round off. Since the number directly behind it is a 6, I'll round this up to 5.8 gram. And that would be the right number of significant digits because that's the least number of significant digits. So when I multiply and divide, I do that. So is the chemical amount of 42.45 grams? Well, the mass of carbon dioxide in this question is 42.5 grams. Molar mass of carbon dioxide is 44.01 gram per mole. And so the number of moles is the mass divided by the molar mass. Again, I can't have more significant digits than the least number. So the most significant digits I can get is 3. So I've got 42.5 gram divided by 44.01 gram per mole. So I get 42.5 divided by 44.01, and I get loads of digits. I can only have 3. So the 0 in front isn't significant. The 9 is, the 6 is, and then I have to round off for the next one. So the next one will be a 6 as well because I round up, because this 6, so 0.9656, is greater than, or 5 or greater, so I round up this number. My last example here is an addition question. And it says, what is the temperature of water that increases, what is the temperature of water that increases temperature by 3.2 degrees Celsius from an initial temperature of 22.66 degrees Celsius? This one probably needs a comment here, but the temperature is going to equal 22.66 or 22.266 degrees Celsius. So that's the initial temperature, and they're going to add 3.2 degrees Celsius. Well, I know this is a 2, I know this is a 5, but this number is where I have to round it off at. And so if I put that into my calculator, and I get 22.266 plus 3.2, I'm going to round it up to 25.5 degrees Celsius, because then this next number is going to make it greater, so we're going to round it up. But we can't have this much accuracy because I don't literally know what these numbers are. So I can't, I mean, I know they're not going to be smaller than that. So this is how we are going to manage our significant digits when we add and subtract. You have to line it up, and you take the least number of significant digits as decimal places. Here, the significant digits are reflected in a multiplication and division by taking the least accurate measurement. Hopefully that helps you understand significant digits.